Alright, so this is October 20, question number 6. This is S1 discrete random. Alright, so as you can see, we have a probability distribution table. This is for a spinner, and they have asked us to calculate EA equals to 3.5. So what I simply do over here is multiply each and every x value with the probability value. So EA is gonna be 1 into 0.4 plus 4 into 0.2 plus 5 into 0.25 plus 7 into 0.15, and that is going to give me 3.5. Alright, so that's EA. For variance of A, I will need to find EA square. Alright, so EA square is simply going to be, instead of doing A into probability of A, I'll be doing 1 square into 0.40 and so on, and 0.20, and then 5 square into 0.25 and 7 square into 0.15. Alright, so EA square is going to be 17.2, and that's the calculation for that. Alright, so I know that EA square is 17.2. So the variance of A is simply going to be EA square minus EA whole square. So variance of A is going to be EA square minus EA whole square. Now remember, this is the variance formula only when doing discrete random. 17.2 minus 3.5 whole square. So the variance is going to be 4.95. Variance and standard deviation, neither of them can be negative. Alright? Neither of them can be negative. So if you're getting a negative standard deviation or variance, rest assured you're doing something wrong. You either copied the values wrong, did some wrong calculation, or input wrong values in your calculator. Any three of them. Alright. The random variable B represents the score on a four-sided die. The probability distribution for B is given in the following table where K is a positive integer. Write down the write down the name of this sort of probability distribution. Alright. So as you can see, all the probability is the same. This means that there's three keywords to this. They are called discrete uniform distribution. You have to write the entire thing. Alright, so that's that. Given that EB equals to EA, state giving a reason the value of K. Alright, so EB equals to EA, that means the expected value of B is also 3.5. Expected value of B, sorry I wrote EX, of B is also 3.5. That means 3.5 is right in the middle. Okay, so you have to state giving a reason. That means there's less focus on mathematics and more focus on logic. So since expected value is the very middle value, right? We know that all average represents middle value, mean and median especially. So I can say since the expected value is 3.5, I can say the middle value is 3.5. That means 1 plus k over 2 equals to 3.5. So 1 plus k equals to 7, k equals to 6. You can either show this calculation or you can simply write by symmetry k equals to 6. You can either show this or write this. So it's just one mark. Okay. The random variable x is normally distributed with mean mu and standard deviation square. Sam and Tim are playing a game with the spinner and the die. Alright, they each spin the spinner once to obtain their value of A, and each roll the die once to obtain their value of B. Okay, so they are each in turns playing the spinner and the die. Okay, their value of A is taken as their value of mu, and their value of B is taken as their value of omega. Alright, so I can say that the mean is A and the standard deviation is B square, right? So A is mean and then B is standard deviation. Alright. The person with the largest value of Px greater than 3.5 is the winner. Alright, so anyone who scores greater than 3.5 is the winner. Given that Sam has obtained values of a equals to 4 and b equals to 3, and Tim obtained b equals to 4, find, giving a reason, the probability that Tim wins. Alright. Okay. So Sam got a equals to 4 and b equals to 3. So for Sam, the mean is 4 and standard deviation is 3, right? Okay. So we're going to be considering this. Px is greater than 3.5. This is part E. Alright. For Sam, we're considering it for Sam, Px greater than 3.5, right? Okay, so if I convert that to z, that will be 3.5 minus 4 over 3. And that will give me Pz greater than minus 1 over 6, right? Okay, so greater than minus 1 over 6, this is the probability that Sam wins. So in order for Tim to win, he must need a greater probability. Now let's consider the bell curve. If I consider the bell curve, for Tim to have a higher probability, thus a higher chance of winning, he will need a value that's lower than minus 1 over 6. Because a value that's lower than minus 1 over 6, let's say this is minus 1 over 6 and this is whatever value, okay? This is the probability that Sam wins, right? If he gets a value that's before 1 over 6, he has a greater opportunity to win, a greater probability to win. That means for Tim, okay, for Tim, the mean was, okay, we don't know the mean. We have to calculate the mean. We have to calculate the mean. His B was 4. That means his standard deviation is 4. That means for Tim, he must have a z greater than value that's smaller than minus 1 over 6, right? So that it sets back, and the greater than that probability is greater than that of Sam. One more time, the probability distribution will look like this: Pz greater than a value. This value must be smaller than minus 1 over 6, because if it's smaller, it sets back, it sets behind minus 1 over 6, allowing Tim more probability to win. Alright, so for Tim, again, Px greater than 3.5. So for Tim, that's gonna be Pz greater than 3.5 minus, I don't know his value of A, so let me consider that A over, I think is, I forgot. So his B value was 4. Okay, so 4. Okay, so this thing, 3.5 minus a over 4 must be smaller than minus 1 over 6, so that it sets some way before minus 1 over 6 and allows Tim more probability. Okay, so if you calculate this, if you simplify this, that's 3.5 minus a less than, I need my calculator, so that's minus 1 over 6 into 4, it's minus 2 over 3. Alright, and then so a must be greater than 3.5 plus 2 over 3, 4.17. Okay, so his a value must be greater than 4.17. So the probability that Tim wins will be 0.25 and 0.15. Greater than 4.17, so that's 5 and 7. So 0.25 plus 0.15. So Tim wins is 0.15 plus 0.25, so 0.75. Alright, so that's that. Okay, let me go to a copy of the question because that one is messy. So E done. Let's do number F. Find the largest value of Px greater than 3.5 achievable in this game. Alright, so x greater than 3.5. Let's consider 3.5 to be here. And let's say the mean is somewhere over here. Alright, so however way you set it, it's always gonna look like this: 3.5 minus mean over omega, right? Alright, so our mu is our a value. right? Our mu is our A value. Let me draw it over here. Say 3.5 is somewhere over here. You can consider it on either side, it doesn't really matter. Okay, so 3.5 and mu are over here. So our probability looks like this: 3.5 minus mu over omega. So in order to get the largest z value possible, the numerator needs to be as high as possible, right? The numerator needs to be as high as possible. For that, you need to pick a value of mu that's furthest away from 3.5 in order to get the biggest difference. So that's 7. And again, to get the largest z value, you need the smallest possible omega. Alright, and omega is 1. So that's 1. B value, 1. Okay, so let's do it. This is part F, I guess. Yeah. Okay, part F. So for the largest value, A must be 7 and B must be 1. So that's P x greater than 3.5 equals to Pz greater than 3.5 minus 7 over 1. Okay, let's calculate that. 3.5 minus 7, that's minus 7 over 2, which is minus 3.5. Pz greater than minus 3.5. Okay, so that's equal to Pz less than positive 3.5. Yeah. Okay, now let's just go to our normal distribution table. Table 3.5 is, where is 3.5? There, 3.5, 0.9998. So this answer will be 0.9998. Next, find the probability of achieving this value. Alright, so for achieving this value, I need A equals to 7 and B equals to 1, right? So I'm simply going to be multiplying them. A equals to 7 is 0.15 and B equals to 1 is 0.25. So part G, all you need to do is multiply those values. 0.15 and 0.25. 0.15, 0.25, and that is 0.0375. And that's it for this question.